Okay, anyway, FRP is on the menu today. That's Functional Reactive Programming. Oh, that's a long word. All right. We can zoom out a bit. And in FRP, you essentially have two things. One of this is an event. The other thing is a behavior. Now, an event can be imagined as a data type that is once a timestamp and data, and a behavior would be imagined as a function from timestamp to data. And behaviors, contrary to events, are continuous in time. So events happen at one point in time, and behaviors can be queried continuous in time. Now, timestamp is a bad word for this, because we're not talking about literal timestamps on your computer, but logical time. What is logical time? Logical time is really anything that grows monotonically. And that's a weird word again. Monotonically growing means it never shrinks. It only grows. For example, if you have an application and you do logging, then this action of logging could be considered as a type of clock. So you essentially take something that that only grows and declare it as a clock. Now, in functional reactive programming, your clock would be the event stream. So things that happen as inputs. So really, logical time is monotonically growing, never shrinking. And the behavior and events are a logical timestamp. My phone is too close to your mic, thanks. Oh, I'm closer to the mic. All right, let's go down a little. All right, so events, time and data, behavior, from time to data. And this is what we're going to use. Now, FRP mostly works for single-threaded processes. And as such, it is exceptionally beautiful to do FRP with GUI programming or games or simulations. So this is where FRP really shines. And yeah, I'd say let's do this. Let's start. Open up a terminal and create a project for this. What should we call this? Yes, that was 5%, but I can go a little louder again. Let's zoom in also. What should we call the project? So what I was thinking to do, I didn't say this, I should have said this before. What I was thinking to do today was a DVD, like a DVD player, Magical FRP, Magikarp. That's awesome. Magikarp's awesome Pokemon. I was thinking a DVD player screensaver, but with custom text on the terminal. Barbara, Magikarp, Barbara. It should also work. So we're going to create a DVD screensaver with custom text on the terminal with Functional Reactive Programming. And we're going to call this monstrosity Barbara Carp. Magic Carp Barbara FRP. Alright, first things first, we gotta edit our package YAML file. I'm gonna keep that here. I think I'm going to use my GitHub no reply email address later. And that's not GitHub user, but my GitHub name, of course. And there we have it. Let's kill that buffer real quick. We're going to have to use some dependencies. After you don't. Yeah, it will evolve. It will evolve. It will evolve into something awesome. The dependencies we're going to need are once the reactive programming framework, and that has a beautiful name by an author with a beautiful name, and it's called Reactive.Banana. Now the author is called Heinrich Apfelmus, and Apfelmus translates to applesauce, and he has some really cool talks on YouTube about functional programming, and he names his project after fruit, so that's awesome. The next thing we're going to need to use is Termbox.Banana, and Termbox.Banana is the Termbox library, but with bridging to Reactive.Banana. And on Termbox.Banana, I have opened an issue, which actually wasn't an issue, but just me being stupid. Anyway, me and the author didn't double check it, so he uploaded a new version with a more complex API, which was really sad, and I hope he rolls it back. So for the meantime, we're going to have to use the previous API release. Because, well, shame on me, I confused him, and he released a new version. Right, see if that works with the dependencies. We go into the REPL, read eval print loop. So I have to build on here. And it turns out I still have some problems here. The Haskell toolchain is really horrible, in my opinion, but it's getting better. So for now we have to pin the dependencies. You have two YAML files essentially. One is the stack YAML file, and the stack YAML file is responsible for giving you a resolver. Now a resolver is a curated set of dependencies, like an enumeration of dependencies that are known to be compatible to work with each other. And if something doesn't work, you usually have to use list it in your extra depths field, which would be Termbox.Banana -0.3.0. See if that works. If it's not, these kind of things feel like you're tuning a guitar on stage, and it's really sad. If they don't work. Should have tested this before. Yep, seems it doesn't work. What does it say? Magic Card Barbara FRP, Termbox.Banana, some specified version. Oh, it says 031. That's not right. Oh, I said Reactive.Banana. I meant Termbox.Banana, of course. And that would be 030. And it still doesn't work. That's so sad. Ah, okay, I have to list both. Ha! Because transient dependencies, of course. And this looks like dependency-wise it's working. Feels more like typical yeah. Yeah, I mean, most of programming really is just dealing with these kind of upstream issues, versions and, I don't know, API mismatches and stuff. So here we have Haskell compiling the dependencies because, well, Haskell is a compiled programming language and it does this for you, for your dependencies. And that's cool, but it takes a while, initially. Also, my laptop is kind of shitty, so... all we can do is wait. Multiple files with the same module name. Warning, multiple files, following paths. Alright, we are in the read eval print loop. Hello world. That works. Awesome. So when we wrote stack new, then the Haskell tool stack created a new project for us, which we can use, along with some files. So the files are here in the source directory and it's called libhs. I think we can keep it like this first. No, we cannot. We have to rename it. And let's do this. Go to source, mv, lib. We're going to call it Magic Card Barbara FRP. And yeah, that's it. And we have to rename it in the application. Doesn't import lib, it imports Magic Card Barbara FRP. And let's import, it's imported qualified as app. And then we can here call app.main. Close that buffer. Project streaming. We had source. Call that function main. I think you can change these defaults somehow. And we're going to export only main. Now if we do stack REPL, it should put us into this module here. Does it not? Browse. We have main and it says some func. Perfect. Change that to hello world. See if it still runs. And it does. Yeah, thanks. We just set up a project. Nice. The guitar is tuned and we are ready to go. So, first things first. For functional reactive programming, we of course need the functional reactive programming library, which is called Reactive.Banana. So let's import that. And we will also probably need to define some different inputs for this. So we can import Reactive.Banana frameworks. That's what that is called. Well, I wish it would end in a permanent solution, but we have something that is called software rot and things age. Okay, the next thing we need is the Termbox library. I'm going to import that as qualified again. That's called Termbox.Banana as TB. Again, reload, see if everything works. That's nice, it does. We have some of these functions here. For example, let's say info on event. Alright, we have input event. So we have event. Let's see what Termbox.Banana. It has one function exposed, and that's called run. So let's look at the type of tb.run, and it will tell us tb.run is a function that ultimately results in some IO type, but this function expects a callback. And this callback in turn is to expect one parameter that is an event of Termbox events and another parameter that is a behavior of int. So let's describe our callback for this. Call a program, and that's an event of tb Termbox event, a behavior of int and int, and ultimately it will result in moment IO behavior with tb.cells and tb.cursor, and let's say it's an event of this. First make it undefined, see if everything type checks. Think it won't, because I added so many brackets. And it type checks, and if I go main, it still prints hello world. And if we now run the program with Termbox run, that is provided for us by the framework, it still type checks, and if we go main, it should error in a prelude error. And it does. The exception is that we used undefined. And undefined is just, you can use it if you are not ready with your type puzzling, because Haskell is a type-safe language, and you will sometimes, or most of the times, just deal with the types and make sure they somehow fit, like a puzzle. But the beauty is, once the puzzle works, it usually, once the puzzle compiles, it usually works. So that's cool. And types are cool because they're documentation for free. So we have a program, and this expects some parameters. The first one is the Termbox event, and the second one is a behavior of size, because this behavior of int and int, it actually describes a time varying function from time to width and height of the terminal. So that's pretty cool. And I would say we start with just drawing hello world in the terminal, right? But with the Termbox library. Yeah, undefined is definitely for people who are not ready. There's another cool operator that's, or not operator, but if you prefix a variable and with some letter, for example h, we use h, and then reload, then you will get precisely what the compiler expected in this variable, what type it expected. So it will say found a hole of type moment.io behavior blah. Now moment.io, I don't want to talk about this too much because it's from the Reactive.Banana library, but you can imagine moment.io to be a description of your application in one moment of time. What do I mean by size? If we close and shrink our terminal, the size varies. And this is, in POSIX compliant terminals, you can query for the size of the terminal. So if you want to make a terminal app, you can make it responsive, like a web browser page, which is pretty cool. So yeah, if you're stuck in the type puzzling, then you can write an underscore followed by a letter, or I mean, you can even call it a word, I think, and it will tell you what it expected for it to type check, which is very useful. And it also talks about a bunch of stuff, which might not be so useful, but once you get used to Haskell programming, it is. All right, first things first, I really need to keep track of what we're doing. First thing, write hello world with Termbox.Banana. You can have a banana of any size, really. So Termbox has two types, sorry. Two types. One is called cell, and it's from char, or it's char attributes and attributes. And this means cell of, for example, G, white and black. So these are the foreground attributes and the background attributes. And for this we have a constructor from TB cell. For example, write an age. And if we inspect the type of TB attribute, why is it not there? Termbox.Banana. I'm switching into the module here with :M. We now browse, we get all the things that it exports. And we have attribute. Alright. If we go in info on attribute, then we can see it exports a monoid instance. Oh, my camera's in the way. Thanks for that. Whoops, this is not what I intended to do. It's all zeros and ones. I remember one time we were at a company meeting and I kept asking people if they were write more zeros or ones, and everybody was confused, and I thought it's the funniest thing ever to ask. But yeah. So attribute. We need attributes for the cell. Okay. These foreground and background attributes. These here. And we get them by using the monoid instance of attribute from the Termbox.Banana library. Now a monoid is something you see a lot in Haskell programming. Let's see what the info on monoid is. And monoid defines some functions. A monoid of type A must define a function mempty that is just some A, so like a default A, an mappend, which is an associative operation, and mconcat, which takes a list of A's and squeezes them into one A. Now, these are some funny functions. If you think of a monoid in terms of numbers and the plus operation, then you will see that empty is actually 0, because anything plus 0 is anything again. So A plus 0 is A. Mappend is exactly the plus operation, it's associative. And mconcat is just taking all the numbers and adding them. So plus is a monoid. Now attributes is a monoid, which means we can make the empty attribute, and we can combine attributes, which is pretty cool. So for the first one, we are just going to use empty. So the empty attributes for some cell of the character H. Type checks, but we still get the undefined because obviously it is still undefined. Now, in order to make a cell be of type cells, this one here, that's the second important type that we have. Cells, I don't know what the constructor is, but you use it with the set function. Constructed by set. And the set function is from int to cell, and then gives you cells. And this is essentially x and y and content. So to draw a cell, let's call it cells. We will use tb set my cell position 0, 0. Oh, like that. And now, next fun part is fulfilling the type. We used to just write undefined, which obviously didn't result in any real program, but we need to return something here. So what will we return? We will return a behavior that is a tuple of an event that never occurs. This is the second event here. This event is to close your program. So whenever this event is fired, your program will close, and for the meantime let's just set it to never. Oh no, let's actually not. Let's set it to tb event, because if I set it to never, then my Emacs is never going to close the program, which is very sad. And the first argument is a behavior of type tb cells and tb cursor. I use tb event because it's just the event that we have here. Now, I don't want to use a cursor, so I say tb no cursor. And the cells that we are going to use are my cells. The function pure takes data and gives you back a constant behavior. So it's logically the constant function in behaviors. It never cares which time it is, it will always result in the same thing. Oh, and we're going to have to use tuple sections here. And it doesn't type check. Why does it not? Couldn't match type tb event with that. Alright, yeah, we have to make it forget what this was. Yeah, this operator here, it takes the left hand side and transforms the event that we give it. It transforms the payload of the event such that it doesn't care what's in there. We could also write a 1, then it would just be the constant event 1. Whoops. Wrong key combination. Alright. And if we go main, then we can compile and we have output on our terminal, the constant character h. If I write anything, it should close the program. And it does. Just write the letter J and it closes the program. Okay, so we know how to write one character. Now the question is, how do we write two characters? We do that by constructing the cells thing with multiple characters. So I'm going to create a function called label that takes a string, some Termbox attributes, and gives you back cells. And my cells will then be, oh, actually we need more parameters. We need a let's call that position X and position Y. We need a position X and a position Y. Okay. And the label function is going to do exactly this thing here, but for many characters and not just for one. So it's going to be, we remember cell is a monoid. Alright, let's look at what monoids are. Monoids have the function mconcat. And we can use this to our advantage by doing an mconcat of a list where we set a character with background and foreground attributes. Oh no, where we create a TB cell with a character of foreground and background attributes. And that character is from the string. Okay, so this is a list comprehension, but it doesn't type check yet because it's of type wait, pause X, pause Y. Still shouldn't type check. Yeah, it doesn't type check because it's a cell now. It's a list of cells which we mconcat, but not a list of cells, because cells with a plural, they have a position also. And we have to set that again also. And we do that by using tb.set at position X, position Y of whatever we put in here. And now we should have a working example. It type checks, nothing is read, but, well, it won't render the string hello world, it will just say D, because we have them all on the same position. We can try that with the empty attributes. And it just says D. How do we get around that? Does anyone have an idea? Because here we set only position X. Alright, we can do this with the zip function. We zip our string with the numbers from position X onwards. We get back a character and an X tick, or like position X, let's call it delta. And now this will always add onto it, because we defined our C and our position to be from the zipping of the string and the position starting at position X, so the initial argument. And now if we say it comes from delta pos X, we reload and call main, it will say hello world. Perfect. Yeah, brackets mostly fix things. And that's right. Especially in Haskell. If brackets don't fix it, then mostly the dollar program, the dollar operator, because dollar operator is just, this is such a cool operator. You take a string, or not a string, you take a function, and that function needs a lot of brackets, but the dollar operator makes it so that everything following the dollar operator is implicitly in brackets, so you can never be sad about not closing your brackets properly. But it doesn't work for tuples, of course, because tuples, you construct tuples with brackets. So now we have a program that prints hello world. And what is the reactive thing now? Well, we have a parameter called bSize. And let's say our string is always at the middle of the terminal. For that, we need some more syntax, but it's actually not more complex. We need the functor syntax. And make the string a constant behavior. Then the applicative syntax, make the attributes a constant behavior. And this thing here, also the constant behavior. This also a constant behavior. And now we have the Y position. And for the Y position, we can take the second of our bSize and divide it by 2. I think we need to do some number rounding as well. But this will give us a string on the terminal that is always on the center. Actually, let's put it here. And yeah, that should work. We still have some imbalanced brackets. Why is that? Or do we? TB cells. Oh yeah, my cells is a behavior now. And that's rounding issues. Yeah, fractional. Of course, we cannot just divide fractionals by 2. But what we can do is div. And if we now call main, I don't have the euro on my keyboard. You can define a function that's called euro in Haskell. It's perfectly fine. And if you do, you can use it as an infix operator like plus and minus. Because every function in Haskell that is written only with Unicode symbols or non-alphanumeric symbols, you can use as infix operators. And you can make your own math with it, which is pretty cool. Anyway. Now the label hello world should be at the center of the screen vertically. And it is. And the cool thing is now Let's open up another terminal, one that I can resize more easily. If I now go stack run, we will see that it compiles a bunch of stuff again because it tries to make a production build now. And if I resize the terminal window, I get the resize event, which is sad. Alright. Okay, let's I can explain this. Currently we close the program at every TB event. But resizing the terminal window is a TB event which closes the program, which is really not what we want. So we have to filter. So eClose, filter E. Let's look at the type of filter E. Oh, it's actually from Reactive.Banana. Okay, it takes a predicate, a to bool, and some event, and gives you back a new type of event. And the TB event, let's load the Termbox module again. Termbox.Banana. Termbox event. Why is it not here? Why is it not here? Oh, it's a pattern. Oh, okay. All right, here we have event key. So we can filter if what we get is event key C and C equals Q. And in any other case, we just go false. I'm going to have to enable lambda case for this, because this is also some non-valid Haskell 98 syntax. But this case expression is an extension. Of course, we have to prefix it. And why does it complain? TB key. Oh, okay, we must pattern match again, because key can be arrows or whatever. We have to match it on key char. This should type check. It doesn't. Because we have to ignore whatever comes out of this filtering. Alright, so if I go main now and run the program, then the text should be at the center. And if I resize my terminal window now, it will stick to the center. So this is perfectly reactive. It's a responsive application. And all of this with just a little bit of Haskell. I mean, it was quite a bit of Haskell, but I think it's still pretty awesome to just have an always centered text with so little effort. Actually, I want to make a new function for this. Yeah, for Google, learn Python with 14. Yeah, I want to make a function for this. It's called key event. Takes a char and gives you back an event. Key event is precisely that, what we just wrote. but not only for Q. So eClose is now key event Q. That should still compile. It does, and it's always in the test center. Alright, so we can write text on our terminal and move it. That's cool. The next thing we want to have is motion, because in DVD screensavers you always have some motion. Things, or like the box that moves around, well, it moves around, that's the first thing, and then it bounces off the edges, right? And we want to describe that behavior. And in order to do this, we also need some kind of event loop, because things, if it only reacts to the TB event that we already have in our program, then we have to hold some key or something or move the mouse to have it simulate. But we want to simulate it on some time frame. So what we need to do is create a sort of tick event. And now Reactive.Banana exposes a function called new event. So we can say tick event is a new event, and we get a function. One is the event stream for ticks now, and a function to fire that event. Let's call it fire tick event. Windows 11 is just Windows 10 with a new GUI. So so to fire the tick events, we need some sort of background thread that does that. So we have to import some concurrency module. Namely fork IO and thread delay. Let's call it ticker. And ticker is, well, it does fire tick event with nothing, then calls thread delay for, well, let's, yeah, 60 FPS. Now let's go with 30 FPS, and then it goes into ticker again. What's 10 to the power of 6 over 30? Well, that's a big number. That's a small number. Awesome. Alright, but we need the big number because thread delay takes microseconds. It takes an integer. Yeah, so that's nice, and we say let's import rounding. I think there's a real frac methods round double int real frac. Called that. What's that called? Does anyone know what the function to round a double to an integer is called? Yes, you can create Bitcoin with Python. Not actually Bitcoin, but you can just make your own Ethereum fork. I forgot float. Float. That's it. Alright. Let's round double int of all that junk. And a type checks. Perfect. So now we get one clock tick every 30 times per second. This is essentially a game loop now, but if you're making a game, you have to not just use fixed frame rendering, because you cannot assume that the machine can really hold up 30 frames per second, but sometimes computations take longer or shorter, and in a real game loop you would have to use something called delta time, and with delta time you measure the time it took from the last computation, and then you use that to compute your next step or your next state in your game, which ultimately means that even if your computer lags, the simulation will still have the same result after an elapsed time. But this is not what we do here. We just assume that the computer is strong enough to render this 30 times per second. We might have some back pressure in the event stream from this, but I think it will be fine. So now we can tick, and let's say at each tick, or not at each tick, but at some ticks, we will have the X position vary. So the X position will be an accumulation of events, and you do that with the accum_b function in Reactive.Banana. And the accum_b function expects an event to happen, which in our case would be the tick event. And when that happens, let's add 1. Okay? So this means, well, we start at 0, and every time we get the tick event, we add 1. Let's put that to our label, and it should be really fast and go away. And it does. Pretty fast, even. So our X position now changes on every tick, and that's pretty cool. Let's say let's assign some speed. First equal to, yeah, let's say 1. Now the X position will be added to the speed on which we tick. And now this is a double, but we want to use round double int of X position. And same outcome as previously. The next thing we can do is do this also for the Y position. Again, with rounding. And what do you think will happen now when we have both the X position and the Y position accumulating their speed? I think you need at least 3 Pythons, maybe even a Python cluster. Okay, so if we have both the speed, then what will happen is it will just race off the bottom right corner. Whoop. And it's gone. And again, and we have it there. And it's actually very fast. Let's say the speed is equal to 0.125. Now it's much slower, which is good. And looks much better because in the GNOME terminal, because it uses back buffering, and the Emacs terminal is just kind of weird. So the string races off to the bottom corner. That's cool. We're getting there, we're getting there. Now there's a problem. The X position is determined by the speed and the Y position also. And the positions are, well, actually what they're doing is they keep adding the velocity. So let's make the velocity and the on the x-axis and the y-axis explicit. So it's xval which is equal to the constant speed, and the y velocity, which is equal to the constant speed. Right, like that. So we have that. And this is now of type behavior double, and the other one also. I gotta enable scope type variables. Okay. So that is that. And now, what we can do is use the tick event to sample this behavior. And the type of this add function, I call it the sampling function, because provided an event and a behavior, you get back the value of the behavior at the event. So what's the type of that? It takes a behavior and an event and gives you back an event of type B. So essentially you are sampling the value of your behavior into the event. And right now it's just a constant, but we can change this. The program still works as intended. And how do we change it? How do we change this? What did we want? We want the text to bounce off the corners of your terminal window. So the velocity in both directions cannot be constant. It changes. And we can say that because we know there are some situations where it will exceed the terminal window. So we can define the box in which the text may move. Like this text. One is the upper left corner, or like the left side of the terminal window, and the top side, the bottom side, and the right side. How do we get these? Well, we can detect a collision with the terminal window now if the position if the position at either side exceeds these boundaries within one tick event. So we have some new events. We have e bounce left, which is equal to when e, now when e is a function, takes a behavior bool and an event and then filters that event essentially. So when e, the position is less than 0, right? Add a tick event. Well, then that's essentially it. So if the position is less than 0 at a tick, then we know we bounce. Same goes for the upper one. But for the Y position. Put some brackets here. The top and bottom position. No, that's the top position. Sorry, e bounce top. The right and bottom positions are a little bit tricky because they depend on the value of b size. But we can still use this. So e bounce bottom equals when e is less than, well, less than b size somehow, or greater than actually. So when something is greater, when e greater equal to b size with height x position is greater equal b size height, something like that. But we have to make a type check. This won't type check because we didn't use behaviors. We used, well, we are comparing behaviors in this sense, but we need to take the comparison into the behavior. So the behavior will be a function from time to a function that compares. So when the x position, we do this with the dollar, is greater than the first element, the second element of b size. Right? And this is now an integer, but we want a double. So what we can do is we compose from integral before it, and now we can compare them, because you cannot compare integers to doubles without converting the types. And now we also have an event of when the bottom is contacted, and I think, well, the same thing is for the right side. Which is not second but first. Oh, and here we need the Y position, not the X position. I'm sorry. So now we have defined 4 events. But our velocity here changes when one of these events happens. But these events, they depend on the X position, which in turn depends on the velocity. So we have a cycle, which is very unfortunate. And how do we fix this cycle? We have cyclic dependencies. We can fix this cycle because Haskell allows you, with the language extension, that is, language extension that allows you to apply a recursive do operation. And that's like super magical, and it's really nice for this type of programming style. In the end, what we are interested in is the x position and the y position. So let's extract them. X pos and y pos come out of mdo. mdo undefined. Now mdo is recursive do notation, and we need to enable it also in the top of our file. We need to enable recursive do, and now we get that. And with this, put it in here. Now we can depend on values that have not been defined before. But on values that are defined later in your program. Why does it complain? Oh, because I need to put them here. That. Haskell is white space sensitive. Okay, now the indentation is right. So now we can use x velocity in respect to the bouncing, because what we can do now is accumulate a behavior with the initial speed and a union. Union is to merge events. We can now accumulate the bounce event to happen. And if the e-bounce left event happens, or the e-bounce right event happens, then what? Well, if we bounced on the left side of the screen, we want to make our behavior to be constant positive. If we bounce on the right side of the screen, we want our behavior to be negative, or our speed. So it will be constant negative speed. And it's actually called unions and not union. And it doesn't work because this is in the moment monad and not a valid let value. So you have to unbind it. Why does it complain here? E-bounce right is applied to few arguments. When E... Oh, I forgot to add the tick event here. Same there. Okay. Now this should give us, let's prettify this a little bit. This should give us the correct events to make our text flip on the right side. But in order to test this, we need to turn off the y velocity. Let's turn that to 0. And our text should bounce on the right side of the screen. After a while. don't know what this... It's getting exciting. And it goes over it, which is bad, but it comes back. It comes back. So we have defined the velocity in terms of the position, which is in turn defined of the velocity, which is some of the things that you can do in functional reactive programming, which is, I think, not so concise in other programming languages, so Haskell really shines here. And it bounces back again. And it will do this now forever. So, what's left is to do this with the top and bottom edges. And we can. Essentially, we just copy this. Yeah, we just copy it. And we don't say e-bounce left, but the speed should be positive if it bounces at the top and if it bounces at the bottom. And it's called y velocity. Let's try to run that. And it should go to the bottom right corner now. It does. Let's hope it comes back. And it does. So I think we're there. Are we there? There's still some things we can do. Let's refactor this my cells thing. Let's call it the text. And we render the text. And the tick event, we can also refactor that, make it tick loop, which is a moment IO event of that. Tick loop equals all of this junk. And it returns a tick event. Returns tick event. And tick event comes out of the tick loop. Perfect. Can get rid of that. And let's not use greater equals, let's try greater, because I noticed that the text disappears for a split second. Huh. Still disappears for a split second. So when the y position is greater than the y position is greater than the bottom. Oh, okay, so it must be greater equal. But it also disappeared from equals, so maybe we have to remove one or subtract one from the width or height. Let's try that. Greater equal and also subtract one. I think this should also work. Yeah. How do you like that? How do you like that? One problem is the right side of the text. It's still, like, it disappears. We currently check for the left character, but we should check for the right one. So maybe if we add some width to it and check with the bouncing on the right side if it overlaps. That could work. So we also want our text to be a behavior. So let be text equal pure that. That's good. And that's now be text. And the text length is also a behavior, but it is a behavior that is inferred from be text. So like that. Now it's a behavior of type int that is also depending on the behavior of this thing here. So if we now, when we check for our right, we can not only subtract 1, but also subtract the size of our string. So when e that it's greater than that on the tick event, okay, that's here. Where are my brackets? There's a bracket missing. So, and on the right side, we not only subtract 1, but we subtract the second argument also. So that's xparse and width. And we nothing. We subtract 1 from the x position. Let's call it just x. Just call it x. And the other behavior that we put in this is the text length. And I have mismatched brackets. And now I don't. Subtract 1 plus width. This should work, I think. Getting errors? Int with double. Ah, okay. Width is of type int, but this subtract thing here expects double. So essentially we can also just go from integral here. And let's not use the subtract function, but just minus. So from x we go minus 1 plus width. I think that should be that. So if the x position is greater than the window size x minus the width. Yeah, that should work. Then we should have it bounce on the right side, but on the D and not on the H. At least I hope. It did, but I think it did it one character too early. I think we can remove one character again. Yeah, so this 1 plus might not be so necessary. Let's actually make the speed a little bit more, like 0.5. Run that. And it's much faster. It's actually a little bit too fast, but it's nice for testing, right? Alright, it pretty much does what it should do. The next thing we can implement is changing the color when it hits in a corner. And we have the attributes for this. When we draw a cell, we have attributes, and we can make it. This is so stupid. Yeah, we can change the color with the attributes behavior. We can make the behavior an attribute and a behavior, and change the color when it hits a corner. I think that should work. I love it. I love this. It's a little bit too fast again. Oh, and the cool thing that we discussed is that we can also resize it, right? So if I shrink it, it will eventually come back. At least I hope. Yeah, there it is. And now the box is just much smaller, the little box in which it is allowed to exist. Alright, yeah, let's change the color. Do the color change. For this, we can also we can just also return an event, eBounce, which just indicates that any bouncing was done, like any corner was hit. So eBounce should be, I think there's a merge function. Is there a merge function? Merge. Let's load Reactive.Banana again. Merge. Yeah, there's merge. Alright. So we have event A and B, and we merge them to event these. Awesome. So what we can do is merge eBounce left and eBounce bottom. Bounce bottom, and then merge whatever we have merged there with, oh, let's call this eBounce right, and merge it again with eBounce top and eBounce bottom. Event A, and then that gives you, alright. Any bounce to that. And we want to completely ignore whatever type there is, so we can just use the forget about it functor. Now we have an event to bounce, for bounce when something has bounced. And we can make the foreground a behavior, be foreground. That's an accumulation behavior of empty. And whenever an event happened of type eBounce, then we change the color. For example, red. Oh, it should be tb.red. And now on the first instance of a bounce, it should change its color. Let's see if it does. And it did. But that's not red, that's green, but whatever. Still changed its color. So the next thing is to pick a random color. Or yeah, let's define a list of some colors. Colors, that's TB red. I have to see what else they export. Termbox.Banana. I want to pick some primary colors, but my terminal color scheme is also screwed, so I guess that's what happened. So we have red, let's take cyan, green, magenta, yellow, white. Yeah, that should be good. So we have some colors. Now the tricky part is to use random numbers. These are a little bit more complex in Haskell because of the IO monad, because it's a side effect, right? Generating a random number will always give you back another random number, so this is not a pure function. And we are not happy if the functions are not pure, but there's a trick. In random number generation, you start with an initial seed, and on each new number you get out of, you get a new seed. And if you carry that seed into the next computation, then you have a pure random number generator again. Except for the initial seed, which you must somehow get. But, well, that's how you can do this. That's how you can do this. So our random number generator should be a behavior. Yeah, I think it should be a behavior. Let's actually make this a little bit smaller. Should be a behavior. Let be RNG. That's from accumulation of B. I mean, we could do IO in this. I actually have to look up about randomness. I know there's some random gen. It's from random. Okay. Then we have the next function. Oh, no longer used. It's deprecated. Okay. There's an integer. Returns an int that is uniformly over the range authored by genRange, including the new generator. Okay. GenRange is also deprecated. So how do you get a new one then? Random R. That sounds awesome. Random R takes a range low and high. Okay. Random, the same as using a default range determined by the type. For floating point types, the range is normally closed by the interval. The closed interval 0 to 1, okay. For integer, the range is arbitrarily the range of int. Okay. So, when there's a bounce happening, we want a new color. And that should result in a new random number generator. Because it does. And we can generate also an event with the new color. Yeah, that's nice. So we have one behavior for the random number generator and one event with the random number. And we have a function for this, for something like that, and it's called map_accum. So map and accumulate. So map_accum in Reactive.Banana takes an accumulator, again, so some initial value, and an event that deals with that accumulator and gives you back an X and the new accumulator, which will ultimately result in an event stream of X's and a behavior of ACC. So what we will have is a event e color change or e new color and a behavior of RNG, which starts with how do we get a random gen? std gen, okay, mk std gen or init. That's cool. Okay, so first we get the first initial generator g, or yeah, let's call it RNG, lift IO of that, and we don't have this. Why not? Oh, we have system.random. Okay, port system random init stdgen. Is that what it's called? Yeah. Oh, system random is on there. So stack file, where's it? Package YAML. There. We want to add random. Now it should be there. After I reload the session, of course. Magic power up. Oh, it failed to thing. Okay, we have system.random. Now the code just didn't compile because I was not careful and didn't write my undefineds there. So that's undefined. Awesome. And it complains, behavior blah. Oh, that's map_accum. It's going to map accumulate. And the variable is not in scope because there's a b too much. Alright. We have system random. And that. Our colors are here. We have some initial RNG. Let's actually put that here so that we don't clutter our namespace so much. G. Our accumulator is G. Right. And in our function, what's the type of this again? What's the type of map_accum? Reload map_accum. Oh, holy shit. Okay. Map Reactive.Banana event accumulator. Okay. So G is the accumulator, and our event now takes this accumulator. So this is some other G. Yeah. Gen and gen, and that's called G. And we are going to use some of these methods here that get us out a new value. So not random IO. What did we say? What was that? Random range or something? No. Next, gen word, gen blah, gen range. It was just called random, right? But I like this one here, uniform. Uniformly distributed. So then we get a better chance of not having the same color after 2 bounces, which would be cool. I think it looks cooler. Yeah, let's use it. So uniform out of, oh no, uniform R. That's it. There we can go from 0 to whatever. Okay. Uniform R from 0 to length of colors -1. Okay, why do I use -1? The documentation here states that 4, which is the upper bound, is also included, and this would result in a bad lookup. So we have let I and gtick equal to that in. We are going to return gtick again, and now a random color, which would be colors lookup I. And uniform R must be imported. Yes, must be imported. There, it's here, uniform R. Do we have that? Does it compile? Does it compile? It doesn't. Why not? Couldn't match type A, B with actual type G0. Oh, because we didn't supply G to uniform R. Try that again. And it still doesn't work, which is sad. It's an event, system random blah 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 TB attributes. G has 1 value, but its type has none. Oh yeah, this is not an event, this is just a function. We want to do this in response to the bounce event. So when any bounce happens, we get a new color. Right? E-bounce. I think that's what we called it. Does it not work still? It's not an attribute. Well, we have gtick here. E new color and B RNG. Actually, I think we can ignore that one. I think it's because I used weird do syntax here. Let's use it like that. Will that work? Still doesn't work. Why not? Attribute. So having an event of new color, we need to. That's an event of TB attribute, and that's a behavior of random gen. Well, of some A. I don't think, because it's a constraint, random gen is a type class, I think we're just going to confuse the compiler even more. Oh, okay. So uniform R. Did I random gen G, uniform A. We put in G, oh, uniform R here. We put in the range that we want, get back G and A. And then for the... I did this the wrong way around, so this must be like that. Let's reload. Okay, that worked. Awesome. So now we have randomness behavior. But actually we can ignore this, I think. I think we can ignore it. But I'm going to keep it here. No, I'm not. I'm not. I'm going to return a behavior here. So the BRNG is completely ignored from return here. We're going to return bColor, which is behavior of TB attribute. So we have BRNG. We have a E new color and behavior RNG, and what we are going to use is a stepper of E new color, which will result in a behavior of type color. Couldn't match moment IO behavior TB attribute with actual TB event, blah. E new color. Did I not indent it enough? Return stepper. Okay, so this is bColor. Couldn't match exact type events. That. Move that here. Why is it complaining? Don't see why. Oh, stepper needs initial value, I think. I think that's it. Is it not? No, it's not. TB behavior TB attribute with TB attribute. Expected behavior TB. Actual is that. Okay. Maybe I shouldn't return it. Oh yeah, stepper is already in monad. Yeah, that's also a moment monad. So we can just use that. Now we have the color as a behavior, and that's a behavior, and then we can just write bColor, and it should give us a new color every time we hit the wall. Actually, we can ignore this behavior here, invoke main, and see if it works. Oh, we got a random color, and we got a random color again. Nice. I think it's invoking 2 bounces. Yeah, it does. Okay, so if it bounces once, it immediately tries to bounce again, and I think this is because we just accumulate the position. But if it goes out of bounds, it shouldn't try to resolve it by accelerating again into the left side, but it should just stick to that. So what we can do is there's 2 solutions now in my brain. The right one, or no, both are right. One is a little bit more hacky. One is to only invoke the bounce left event if the acceleration is negative, because if it's positive, it cannot bounce again. And the same for the other ones. So this would be a filter E of velocity greater than 0. And I think that's a simple solution. So that's filter E. Filter E of xvel, x velocity of whatever, and that being greater than 0. I think that should work. Gotta put the syntax here again. See if it type checks. My Emacs is running slow right now, I think because I streamed so long. It doesn't. It's expected type whatever to bool with actual type behavior bool. Okay, so it must be constant. Const. No, it mustn't. Here it must be constant. Why not? Behavior bool with bool. Expected blah to bool, actual behavior bool. Oh, it's when E. And that's also gone then. Okay, same for right direction. When E. And we can only bounce to the right if the velocity is positive. So actually flip these. If that's less than 0, and when that's greater than 0, of xvel, then we should bounce right. Or moving to the right. Moving to the left. Same here. When E, we can only bounce to the top if the velocity is negative on the Y. So if it's less than 0, on Y velocity. Then we do that. And same here, when E is greater than 0 on the Y velocity, then we can go there. And that should fix that problem of the double bouncing. Let's reload. What's it called? Stack run. Stack run. And shouldn't double bounce anymore. What's gray? Blue. Okay, I think we fixed that bug. Yeah, we did. Okay. This is so ugly. What the fuck? When did this happen? Put some of these here. Usually U lines help, but I think they just make matters worse now. So when that happens, actually let's use a formatter. Yeah, that one, just for Mulu or whatever it's called. And now we have it auto-formatted. Okay, so we have these things now. And that's the text hello world. Okay, the last thing I want to do is provide an argument of what we want to render, which is the text. We're going to have the behavior of the text be constant. Theoretically, you can change the text on the fly now too, but let's not do that. Let's get some system environments, args, like I think it's called system.environment.args. Is it that? See, system.environment. Okay, what do we have here? With args, unset args. Get args, okay. So get args is a list of strings. System environment get args, and that's args out of get args, obviously, and then we just concat args, or let's actually I think it's called unwords. That's the function that removes spaces in a list or adds spaces, I think. That's clear. Unwords. Yeah, takes a list of strings, gives you back a string. Awesome. So unwords. Yeah, essentially that. So unwords with args. Does that not work? No, it doesn't. It has to be here and then like that, because the functions it's point free. Yeah, and if you put the dollar there, then it thinks that we want to apply. No, it doesn't. That also works. Okay. Not that one. No, that one doesn't. Alright. Thought so. This obviously doesn't. So, yeah, let's just stick with that. Now it should take the arguments here, and if we write nothing, then obviously nothing's written. Args should be like I want to add some default to this. Let's say should be the default. It should say Magikarp. Yeah, now it says Magikarp. Goes. Does it always take the same colors? I think it does. I think init.stdgen is not what you should use. Yeah, now it's gray again. Now it's white again, and then I think. But white, gray, white. That's like super non-random. Oh, but it is random. All right, I didn't say anything. Maybe I need to add some more colors. Maybe. That's so much code already, holy shit. Really underestimated this. Yeah, the colors. They are down here somewhere. Where's the color? There. Termbox.Banana. Stack grapple. Let's browse. White. Red. Red, cyan, green, magenta, yellow, white, red. Oh, we can add blue. TV blue. And I think we have yellow already. Okay. Yeah, and black. Let's add black. Because most people generally just have the terminal a little bit bigger. I want to take this function here and make it a new, like take it into a top level function. Like this. B color is of type moments IO with some behavior, because it's a complex function. There's a bracket too much, and I think I'm missing some events here. Yeah, okay. So we take some events, just event A. In response to any event, we generally can do this color switching. Let's B color in response to any bounce. E bounce. Let's also move. Oh, why is it complaining? Because of course, yeah, it's monadic still. We didn't get it out of the moment IO monad. So let's say make random color. I think that's okay. There are worse names. Any suggestions from the chat? I mean, there's so little questions also. Maybe this is just smoking everybody's brain. But we will see. So B color is out of make random color in response to E bounce. And then we have it here. All right. And this block here, to also get this out and call that simulation, or yeah, let's call it make simulation behavior. that is equal to all of this junk. Right. And it's just equal to mdo that, this and that. Oh, and we need the size and some tick event. So tick and bSize. Simulation behavior takes some events of anything and some behavior size, behavior int, gives you back moment IO of 3 behaviors, really. No, 3 things. One is the behavior of the position on X, one is the behavior on the position on Y, and one is the behavior, no, one is an event stream, I think, if things bounced. Type X position behavior int, and same for Y position behavior. Oh yeah, obviously. And type bounce event. X position behavior, Y position behavior, and bounce events. Oh, and it needs the tick event to simulate, essentially. And bSize yeah, and another behavior. Damn, okay. bSize and what? bSize. Oh, right, the screen position, the screen size, obviously. Okay. And bSize and bWidth, or object width or something. And that's the object width here. Okay, and we have X pause, Y pause, E bounce coming out of make simulation behavior with the tick event, the bSize, and the bText length. Why does it complain? Match type int with double, expected behavior double. Oh yeah, it is a double, it is a double. I said it's an int, but it's a double. And it compiles. All right. I'm going to let the formatter run on it. And I think that's pretty neat for now. And I really like that you can resize it. Although I fear, oh no, there it is again. Cool. So that means in the other videos we can just have it running in a loop, which is also a nice integration test, right? See if there's any memory leak. I think that's pretty cool. And I really like the way you write these things, especially this one here, where you really have to define your dependencies, because, well, the velocity changes in the case of a collision, but a collision can only occur when we know of the position. And, well, there's that's just a really cool way of describing your dependencies, I think it is. And we have the magic carp bouncing around now, and we can provide other parameters too. I think like this, it should, yeah, like that. So we can say hello or hello world. This is a really long string. See if that works. Yes, it does. Now I'm interested. If the string is so long, how will it behave if we shrink the window? My guess is that it tries to bounce in both directions, so it will jiggle. I think it will jiggle. Let's see. Yeah, it's jiggling. Oh, and it keeps changing its color. That's cool. It's kind of cool. And I'm wondering if it's really keeping up with 30 FPS. Because if it's not, then there will be probably back pressure. That means that the thread that is sending the tick events will make some internal queue overflow eventually, I think. But maybe Reactive.Banana is smart enough to block things, or to have some overflow protection. Maybe it's even like a semaphore, and you... no, not like a semaphore, but like an MVAR, and you can only put one thing in it. Like if you fire something, you cannot fire again until someone consumed it. I could imagine that also. But yeah, we have a stupid DVD wall screen. What's wall screen? Screensaver. Stupid terminal window here. And try it in Emacs. I'm gonna try it in Emacs. I have to. So I already have the terminal, of course. Reload. Main. Holy shit, that looks horrible. Okay, in Emacs it's really horrible, because the attributes are wrong. And also it's... oh, it's taking the size of the lower buffer here. Okay. Yeah, because... well, of course. Okay. This buffer here now determines its size. That's why it looks so weird. Segmentation fault, core dumped, stack wrap. Oh shit. Well, it's none of my problems. Stack run. Like that. Exactly. Okay, and if I move my cursor now, can I just code? Oh, it's invisible. Why is it invisible? Oh, there it is again. Yeah, awesome. Okay, some attributes don't work so well in Emacs, probably because of my color scheme. But yeah, as always, there's tons of things we can improve. There's some boilerplate, some duplicated code that I might improve if there's interest in it. Generally, these kind of things, we can make a function of these and just say, hey, it depends on that on every tick, like on tick or something. But I think it's okay. I think it's really okay. So yeah, I hope you liked this practical example on using Reactive.Banana together with Termbox.Banana. when I uploaded it, there will be a link in the description to the GitHub repository. I'm open for every issues you encounter. Maybe I did something wrong. I never know. Like, take things with a grain of salt. I hope you enjoyed it. I hope if there's any questions about functional reactive programming or Reactive.Banana, that maybe they appeared here. Maybe an answer appeared here. And I thank you for watching. Bye bye.